to the quality of the connection, please let me know, and then I will shut off the camera. Okay?
Yeah.
Good.
Yes. I think we have got total 130, approximately 140 participants.
Yeah, actually are connected on 142.
This count will go up because we were in a break actually. So now, as soon as we start, this will go up.
Okay, good. Nice.
I think we can start. So we have
Okay.
almost 140 members. Yeah. So let's start. So you can share your screen.
Yes,
Am I
sure.
audible? Tanmay sir, can you confirm, please?
Yeah, absolutely.
So, so again, we are back and welcome back everyone once again. And so this is the session after a quick recess that we have, and now we are continuing our sessions for technical sessions. So onboarding our next speaker with us, Mr. Gianluca Spadaro, who will present on sustainable erosion control solutions with geosynthetics. Mr. Spadaro is working as business development manager at Officine Mecaferri, Italy, taking care about India and Southeast Asian and Pacific region. He has more than 20 years of experience in geosynthetics and industrial material markets, during which he has collaborated with most prominent companies in this sector. Over to you, Mr. Spadaro.
You. Please just confirm that I'm audible.
Mr. Spadaro, we can see your notes as well. So maybe if we can switch to, yeah.
Okay, okay. Let me do it this way. Let me do it this way. Okay. Is visible the note or
Currently, your screen is not shared.
not sure? Let
Yeah.
me check again.
Yes, please. It's perfectly fine now.
Fine? Okay, good. Okay, sorry for the inconvenience. Let's start with the presentation. Just having a look on the matter that will be touched along the presentation today. After a brief introduction on soil erosion processes, we will recap briefly the different type of geosynthetics used in erosion control application as per the relevant ISO norm, ISO 18228 Part 8. To have then a quick look on two Mecaferri solution destined to erosion control application. Then we will go deep into the research that's been carried out along the year by our company, by Mecaferri, in order to develop sustainable solution to prevent soil loss and promote a full revegetation on slope. Today, just to avoid any misunderstanding, we will focus our attention on soil erosion processes on slope, on dry application. We will not touch the use of geosynthetics in order to limit and erosion due to storm water. So on wet application. Then we will close the part dedicated to the research and the testing with the testing campaign that has been carried out at the TRI in the US, to close with some case studies related to the application of our solution. Soil erosion is a soil degradation process consisting in the detachment of the topsoil due to the action of the natural forces. Once detachment occurs, soil particles are then transported away. Natural erosion occurs typically on a geological time scale, but when human activities alter the landscape, then erosion processes can be greatly accelerated. Water and wind have to be considered the two most common causes of soil erosion. Then rainfall may generate a displacement of the soil particles close to the soil surface due to the impact of the raindrops. The consequent runoff can be responsible of the carving of small rings and channels on erodible soil. And finally, strong winds may bring in suspension fine soil particles and may be cause of the movement by bouncing and rolling mechanism of the larger one. Natural vegetation, if well established, is usually considered a sufficient protection against erosion, as vegetation coverage is typically able to physically protect topsoil from the action of the eroding agents, and plant roots are capable to hold in place vegetative soil, preventing it from being blown and washed away. Based on literature data, a vegetation coverage of 80% for clay soil and 70% for sandy soil can be considered an acceptable protection against erosion processes on slopes and embankment. But this percentage can be difficult to be reached on site, and even if reachable, there is anyway a time window until the full development of the vegetation, during which soil is at the risk of erosion in case of intense rainfall. A paper from Rickson and Loveday reports that the full establishment of the vegetation may require 1 or 2 growing seasons in temperate climates. Even longer on harsher site, in tropical conditions, the fuller vegetation on a slope may take considerably less time. That's the reason why erosion control products made of with synthetic or organic fiber, biodegradable fiber, are then frequently used in protecting slope from erosion and in promoting favorable conditions to the establishment of the vegetation and the growth of the vegetation. Over the year, McAfee has been cooperating with the most important and the most prominent university and testing institute, third-party testing institute, to develop sustainable solutions preventing soil loss and promoting the revegetation on slope and riverbanks. Along the presentation, we will go through the most relevant researches and studies. Let me go through first to the classification of the erosion control product according to the relevant ISO norm, again, 18228 part 8. This actually is under publication, will be published shortly. Geosynthetic addressed to erosion control application can be classified basically based on product configuration. Then we have GeoMat, Grid, GeoWeb, and sheet can be also classified based on the raw material which they are made of. And then, as we have anticipated in the previous slide, erosion control product can be manufactured using natural biodegradable fibers such as jute, coir, or artificial fibers such as polypropylene, polyethylene, and polyamide. And can be also classified based on the duration of the protection. And then can be classified in temporary, temporary erosion revegetation material and permanent erosion revegetation material. Let's have a look on the permanent erosion revegetation material. Let's have a look on PERMs, since they are the material capable to provide a long-term protection on slope against erosion processes. As terms, temporary erosion revegetation material are capable only to promote the development, the establishment of the vegetation, and the vegetation itself is the real protection against the erosion process. Let's then focus on permanent erosion revegetation material. Let's focus on PERMs. PERMs provide a permanent protection since they are made of with synthetic fiber capable to last in long term, are capable to promote the vegetation growth, and if well entangled with the vegetation, are capable to provide a reinforcement of the root apparatus. Then PERMs can be classified basically in turf reinforcement mat, when topsoil and seeds are infilled into the mat, and then the roots can grow through the turf reinforcement mat, getting then an improved resistance to shear stresses, and can be classified in erosion control rolled material when erosion control products are laid on the slope without being filled with the soil and seeds. And then the root develop below the material, and the vegetation can get only an improvement in terms of resistance about the stems, not about the roots of the vegetation. Let's have a quick look into the McFerry solution addressed to erosion control application. Basically, McFerry erosion control solution involves a three-dimensional mattress that falls under the brand name of McMat. It's made of with polypropylene monofilaments tangled together to form a three-dimensional, highly deformable mattress having a thickness between 10 and 20 millimeters. The mattress can be reinforced both with polymeric reinforcement geogrid or double-twisted steel metallic mesh. Having a quick look on the technical datasheet of the product, we may anticipate some of the performances that will be analyzed deeply along the presentation when we will discuss about the research that has been carried out along the year by McFerry. Then light penetration and ground coverage and C factor are the crucial parameter that describe the performances of the material. Light penetration, as you can easily understand, is directly correlated to the capability of the material to ensure the germination process and then the development of the vegetation. The ground coverage is directly related to the capability of the material to protect physically the soil against the action of the eroding agents. And the C factor, as we can see later, is directly correlated to the capability of the material to limit the soil loss and then creating a favorable condition to the development of vegetation. As our commitment is to promote sustainable solution, our materials are covered by the EPD. What is an EPD? EPD is an independently verified and registered document communicating in a transparent and comparable manner information about the environmental impact of a product along its life cycle, accordingly to the relevant international standard. Our solution addressed to erosion control application, as we have seen based on our MACMAT, are covered by the dedicated EPD, covering the product stage, the raw material supply, transportation, and the manufacturing of the process, and the end-of-life stage related to the deconstruction and decommissioning of the material. As we have seen before, let's go through deep into the research that has been carried out along the year by McAfee, starting from the research carried out at the University of Milan. Research has been performed in order to reply to the question shown in the slide: what influenced the growth of the vegetation slope? To reply to this question, related to the factor influencing the growth of the vegetation slope under an economic point of view, we have commissioned to Professor Bischetti, the head of the Department of Agricultural and Environmental Sciences at the University of Milan, a research focused on the relationships between erosion control products and vegetation growth, aiming to identify the main factor affecting the revegetation success. The study identifies 7 product-related factors: light penetration, thickness, color, water absorption, weight, roughness, and runoff, and uniformity, finally, affecting vegetation growth, plant growth, through 4 site-related factors: albedo, soil humidity, water runoff, and soil temperature. The performances provided by an erosion control product depends on complex processes resulting from many different factors and features interacting each other. It is the balance between these factors that provides the best performance in terms of vegetation growth. Erosion control products have been divided along the research into 4 categories: bionets, light geogrids, geomats, and geoblankets. Bionets are erosion control products, bidimensional erosion control products made of biodegradable natural fiber in a form of net. Light geogrids, same, but made of manufactured using synthetic fiber, can be multi-filament or extruded one. Geomats are 3-dimensional matrices made of synthetic monofilaments. And finally, we have geoblankets, natural or synthetic fiber held together by 1 or 2 geogrids. The performances of the 4 erosion control product categories that have been shown in the previous slide have been evaluated in reference to the 7 product related factors that we have seen in the previous slide. Then light penetration, thickness, color, water absorption, weight, roughness, and uniformity. The effect of each factor has been associated to a value range between 1 and 3, where 1 corresponds to a detrimental feature having a negative effect on vegetation success, 2 correspond to a neutral feature having no effect on vegetation growth, and 3 correspond to a beneficial feature providing a positive effect on the development of vegetation. The performance of the 4 product categories that we have seen before, bionets, light geogrids, geoblankets, and geomats, has been represented through a radar chart representation. The value of each factor providing the contribution in terms of erosion protection against erosion processes has been then connected with a segment to create the radar chart area. The extension of the area is directly correlated to the performance provided by each of the product categories that has been analyzed. Then, the larger the area, the better is the performance. As you can see easily in the slide, the area correlated to the geomats product categories is the larger one. So it means that geomats are capable to provide the best performances in terms of protection against erosion, since the area correlated to geomats is the larger one. The solution provided by McAfee addressed to erosion control products that, as we have seen, are based on our MACMAT, are then falling in the geomats product category. So it means that our solution can be considered a solution having the best performances if compared to other geosynthetics addressed to the same scope. But some of the features provided by our solution, our MACMAT, can be considered beneficial if compared to the geomats category. I'm referring to color and weight. Why? Because our MACMAT can be provided in different color instead of typically geomats are provided only in a black color. Why? The capability to provide material in different colors can be considered beneficial in terms of erosion control application. As the capability to provide material in different colors may have an effect on the control of the temperature. So it means that in hot climate, the possibility to have the material in light color instead of in dark one as the black color may help in reduce the peak of the temperature, having a beneficial effect in terms of germination. The opposite, in cold climate, having the material in dark color can be something that beneficial in terms of germination and then development of vegetation. And finally, weight, but only for our MACMAT coupled with the double twist steel mesh, is having a weight that finally is twice time the weight of a standard geomat. That also this can be considered beneficial in terms of protection against erosion, since a material heavier can keep in tight adhesion the material with underlying soil, having a beneficial effect in terms of germination. Parallel to the research that carried out at the University of Milan mainly focused on agronomic aspect, we have carried out two separated testing campaigns. On the left at the Colorado State University, and on the right at the TRI testing facility in the US, more focused on the engineering aspect to evaluate the performances of our solution, of our MACMAT in protecting riverbanks and slope, respectively, from stormwater-induced erosion and rainfall-induced erosion, according to the relevant standard that are the ASTM 6460 for erosion induced by stormwater, and the ASTM 6459 for rainfall-induced erosion. Both of the standards require full-scale testing procedure. The test conducted by the Colorado State University, even if performed according to a standard, evaluated the performance of the erosion control products in protecting earthen channel from stormwater-induced erosion, gave us an additional confirmation about the superior performances in terms of revegetation, proving that our MACMAT allow to obtain a full revegetation in only 6 weeks, delivering in only 1 month and a half 60% of the performances targeted at 1 year time. But let's focus our attention on erosion control on slope, then on the testing campaign that has been done at the TRI US facility according to the ASTM 6459 standard. Erosion control solution, the design of the erosion control solution is typically suffering from a lack of rigorous scientific approach. Typically, the selection process of the erosion control product in most of the cases is driven by the knowledge according to previous experience. Instead of monitoring and modeling erosion processes may contribute to have a better understanding of the causes of the soil erosion processes, making at the same time soil loss prediction more reliable and helping in the identification of the preventive and restorative strategies to control it. The most common model for predicting soil loss induced by the action of the rainfall and the consequent runoff on slope is the revised universal soil loss equation, developed by the Agriculture Department of the US in the late 60s. The revised universal soil loss equation, the Russell equation, provides a prediction of the soil loss due to sheet and real erosion on slope. It can be then used to identify the most critical areas subjected to erosion and to estimate also the benefits provided by the corrective measure under evaluation. Russell formula is a universal formula. It is then applicable in any geographical region, but it requires a proper database for the estimation of the different factors included in the formula. Russell equation is expressed by the formula shown in the slide, where A is the estimated average soil loss, R is the rainfall runoff erodibility factor, K is the soil erodibility factor, L and S are the slope length factor and the slope steepness factor. C, the cover management factor, and P, the support factor. As we have anticipated around the introduction, Raster formula will be included in the relevant ISO norm that will be published shortly. Let's go through the different factors. The rainfall and runoff relativity factor, the R factor, depends on the local regional rainfalls. R factor can be estimated then strictly based on local regional pluviometer readings. However, there are many empirical formulas based on statistical analysis of many years of pluviometer readings, in some cases validated through direct erosion measurement, providing an evaluation of the R factor. K is the soil erodibility factor and evaluates the tendency of a soil to be eroded. K factor depends then finally on the soil composition, the soil texture, expressed by the respective percentage of the different type of soil, clay, silt, sand, gravel, and so on. And depends also on the soil hydraulic conductivity. As we have seen for R factor, there are many empirical formulas implementing soil texture and hydraulic conductivity, providing an evaluation of the K factor. Then we have finally the slope length and slope steepness factor, L and S, that refer to the length of the slope and the steepness of the slope, that you can understand easily can have a big influence on the intensity of the erosion processes on a slope. Then we have the most important parameter, the C factor, that represent the impact of the cover and management system. Cover depends on the type and density of the vegetation on slope under evaluation, and the management system refers to the erosion control solution applied to protect the slope from the erosion processes, which may consist in the process that we are typically called to evaluate in the different type of the erosion control products that we have mentioned at the beginning of the presentation. C factor for a specific geosynthetics can be only estimated through full-scale test on real slope under natural rainfall, or more easily, of course, through a large-scale lab test on a standard plot equipped with a rain simulator according to the relevant standard represented by the ASTM D6459, describing the standard test meter for determination of the erosion control performances in protecting a slope from rainfall-induced erosion. C factor is ranged between 0 and 1. The lower the C factor, the better is the cover and the management system is in controlling soil erosion. So it means that for a bare soil, a slope not protected by any kind of system, C factor will be equal to 1. Instead of for a slope protected with an erosion control product, it will be lower than 1, and will be lower as much the material will be capable to protect the slope from erosion. Then finally, we have the P, the support practice factor, referred to the support agricultural and landscaping practice to reduce the intensity and modify the flow pattern of the runoff, such as contour farming, strip cropping, and terracing. And typically, this P factor is taken equal to 1 in construction project to take a conservative position. Russell equation is something quite common in the US, not so common in Europe, but is something that is already included in the Indian norm. I'm referring to the RCA 56 that is clearly mentioning the Russell equation as a method in order to estimate soil loss and then evaluating the performances of the different erosion control solution. Just to give you a rough idea regarding the capability of erosion control product to protect a slope from erosion, just let me share an evaluation done according to the Russell equation for an unprotected slope and a slope protected with our MACMAT R1005. So it means our GeoMatrix reinforced with a polymeric reinforcement geogrid. For a field slope having a length of 20 meters, an inclination of 30 degrees, an area of 10,000 square meters, evaluating the soil loss along a duration of 1 year, you can see for base slope, unprotected slope, we'll have an average soil loss of 570 tons instead of with same slope but protected with our MACMAT R1005, the average soil loss will be reduced from 570 to something more than 14 tons. The evaluation of the average soil loss can be conducted using the dedicated tool freely available in our eDesign platform. The tool is under the name EcoMac, and it consists in two main tools. EcoMac R providing the evaluation of the average soil loss, and EcoMac S providing the calculation, the estimation of the stability of the our MACMAT on the specific slope. There is an additional tool that can be used for riverbank application, not in wet application, but the presentation today is focused on slope application and dry application. Then let me close in the remaining 5 minutes presenting two case studies related to the application of our solution, of our MACMAT in protecting side slope for a railway project and an highway project. The first case study refers to the application of our MACMAT in protecting from erosion the cut slope along the railway connecting Dar es Salaam and Morogoro in Tanzania. This was the first section of the line connecting Tanzania and Congo, passing through Uganda and Rwanda to give them access to the Indian Ocean. The slide provides an overview of one of the sections protected with our MACMAT infilled with hydrosaline just before the development of the vegetation. This picture shows, instead of the rills and gullies carved into the side slope of the railway line by the runoff induced by the intense rainfall in the area. The original solution proposed by the consultant or the contractor supporting the contractor involved in the project to protect cut slope from erosion was based on geocells. The slide shows clearly the failure of the solution tested in a dedicated area with geocell partially empties and no development of vegetation. If the slope inclination indicated as alpha in the slide is lower than the angle of repose of the infill soil indicated as phi, Provide the application of an adequate erosion control product to protect the infill material, a solution based on GeoCell may work properly. Instead of, if the slope inclination is higher than the angle of repose of the infill soil, as soon the slope will be exposed to the action of the eroding agents, the infill soil will tend to accommodate according to its natural angle of repose, causing the failure of the solution based on GeoCells. We have been then requested by the contractor to support the consultant in the definition of an alternative solution. And we have then proposed the application of our MACMAT in combination with Hydroseed. The picture is related to the results of the test done on site to evaluate the effectiveness of our solution in terms of revegetation. On the section with vegetation development on top, has been installed our MACMAT and then has been done the hydroseeding. On the right, just bare soil shaped and then hydroseeded. The picture is self-explaining, I think, I trust. Here you have some picture related to the installation of our MACMAT, starting from the anchoring on the top that can be done by excavating a small anchoring trench or by the application of an adequate number of metallic pins, J pins. Then the mat properly installed on the cut slope, taking care to ensure a tight adhesion between the geomass and the soil to ensure the most favorable condition to the germination of the seeds and the development of the vegetation. Again, a picture related to the installation of our MACMAT, reinforced with the steel mesh. Then hydroseeding, carried out using a specific mix defined according to the project site condition, according to exposure, precipitation, humidity, moisture, temperature, and so on. And then the results some weeks after. Again, I trust self-explaining. Then let me close with a project carried out in Turkey near the Black Sea on the side of the Amasya Highway that has been cut through a mountainous area, and fine soil and frequent rainfall result in a superficial slidings affecting the road safety and forcing the authority to close the road from time to time during cleaning works. Then has been installed our MACMAT. In this case, as we have seen before, our MACMAT can be provided in different color since project site was suffering from high temperature. It has been decided to use a beige color in order to reduce the peak of the temperature. The installation of our MACMAT along the slope to get the material in tight adhesion with the material, pins with a frequency of 1 pin every square meter, and then the slope on the left after the hydroseeding process and the development of the vegetation. Again, self-explaining, I trust. So, I have concluded my presentation. I don't know how we are organized. If there is any question or any discussion after the presentation, please let me know in case of any question.
I hope I am audible.
Yeah, sure. If there is
Okay.
any question, please let me know.
So, thank you, Mr. Spadaro, for it was a quite insightful and illustrative presentation that we had from your side. And so on this, as you said that, please feel free to type your questions in the chat box because we'll be taking the Q&A session after 2 more presentations. So now we are,
Okay.
yeah. So now we are quickly moving to the next presentation of the second half, which is by Dr. Ratnakar R. Mahajan, Regional Technical Manager at Mecaferry, who will present on advanced solutions for debris flow mitigation. Dr. Mahajan leads geotechnical initiatives across India, Southeast Asia, and Pacific region. And he's an IIT Bombay alumnus. He specializes in soil reinforcement, ground improvement, and contributes actively to BIS, IRC, and ISSMG. So with this, I would like to welcome Dr. Mahajan.
Very good afternoon. I hope I'm audible. Am I audible?
Yeah, sure.
Hello? Yeah.
You are audible. Go ahead.
Thank you. Sumit, Tanmay sir, can you confirm you see the screen?
Yeah.
Yes, we can see your screen, Doctor.
Okay. So I'm going to discuss the solutions for debris flow. At the start, I will just brief about Mecaferry India. Followed by then we will have an introduction of the debris flow, as well as what is the risk and how exactly we take care of risk, giving an example from the rockfall solutions. Followed by then we will see what are the different let's say the topographies and the areas where the debris flow originate. Very briefly touching on the design part, followed by the case studies, few case studies of debris flow, and then the summary. So Mecaferry has a global presence worldwide in more than 100 countries with 2,500 plus or let's say 3,000 plus employees with 70 subsidiaries and 23 factories. Mecaferry India, that is Mecaferry Environmental Solutions Private Limited, which is a completely owned subsidiary of Apicino Mecaferry, started its operation in 1998. And we have a company for the construction, that's Mecaferry Infrastructure Private Limited, which is specialized in executing various challenging jobs, typically including the environmental protection projects. And as a part of India region, we have Mecaferry Nepal, which is a subsidiary of again of Apicino Mecaferry, which started its operations in 1995. We have completed more than 1,200 projects, and we have a strong team of 250 plus employees, which are continuously working, solving the technical issues and the problems faced by the customers. We have the production plants, one at Maharashtra, that's the place Ranjangaon near Pune. The second plant at Una in Himachal Pradesh, the third one in Nepal. Mecaferry, we work in various areas of the, let's say, the environmental market in this, like solutions related to the fencing wire or concrete flooring, solutions related to the aquaculture or net cages. When we are building the infrastructure on soft soil, so solutions related to the basal reinforcement, typically stabilizing the granular layers, that's the soil stabilization using geosynthetics. May it be the solid waste or hazardous waste that's being taken care by the environmental and landfills, including even the dewatering if there are slurries which are being floating, so dewatering them. Works related to the rivers, streams, channels, that's we classify under the hydraulic works. Then the works related to the architectural works, that's the landscaping ones. Our strength is, of course, in the retaining walls. We offer a variety of retaining walls from small height to very tall structures. Solutions related to safety and noise barriers using our universal solutions. Solutions related to the coastal protection, so related to the sea, where nowadays we have an issue related to the severe coastal erosion. So solutions are related to the coastal. And then we are looking at the solutions related to the tunnels and erosion control. Apart from that, when we build the infrastructure in hills, then we have the instabilities of the slopes, which can lead to the rockfall protection and the snow avalanches, as well as the today's topic of debris flow barrier. So people and the assess as per the global assessment report made by United Nations, for disaster risk reduction, you will notice that the world is being exposed and to a growing mixture of hazards and risks, especially places to an extent previously unrecorded. So the alarming rate of occurrence of this natural disaster is one of the concern. And of course, in an interconnected world, losses incurred from natural disaster affects the individuals, critical public infrastructure and ecosystems on which individuals and the firms depend, as well as the broader economic and increasingly complex environment in which the public and private sectors operate. When facing a geohazard problem, we deal with risk. The risk can be defined as a product of hazard by exposure, by vulnerability. They are defined as like the hazard, like the probability that the natural phenomena such as let's say debris flow or rockfall, or may other kind of geohazard you want to say, of a certain intensity occurs in a certain period of time in a given area. Exposure or exposed value is basically the number of units or value of each of the risk element present in the given area, such as it could be human lives or the settlements. And then the vulnerability of an element could be people, could be infrastructure, buildings, or economic activities. This is nothing but the propensity to suffer damage as a result of the stresses induced by an event of a certain intensity. So if you have or you multiply all these three factors, that is hazard, exposure, and vulnerability, you can call it as a risk. The approach to geohazard mitigation, be it the rockfall or debris flow, is based on a risk assessment and the risk treatment. It starts with characterization, like typically the instabilities, then the risk analysis, the level, probability, consequences, and its evaluation. And then moving onwards to identification of treatment options, implementation of risk treatment, and then monitoring and review of the performances. So this approach of risk assessment and risk treatment has to be kept in mind. Wayanad, a scenic hill district in the northern part of Kerala, in India, which forms a part of ecologically sensitive Western Ghats. While the region is known for its lush greenery, spice plantations, and biodiversity, it is equally prone to natural disasters, particularly landslides and debris flow. These events, often triggered by intense monsoon rainfall, have become increasingly frequent and severe, posing a significant risk to human settlements, agricultural land, and critical infrastructure. Whereas debris flow, a rapid down slope movement of saturated soil, rock, mass, or organic material, is a common geomorphic process in the steep slopes of Wayanad. Unlike slow-moving landslides, debris flows are fast, turbulent, and highly destructive. They typically originate in areas where the topsoil is loose, vegetation cover is sparse or disturbed, and drainage is poor. When higher intensity rainfall infiltrates these slopes, it reduces soil cohesion and builds up the pore pressure, ultimately leading to slope failure. The result is a moving mass of debris that can travel hundreds of meters or more, engulfing everything in its path. A major debris flow event in Wayanad occurred in August 2019, followed by an unprecedented rainfall caused by a monsoon depression in the Bay of Bengal. The Epadi region, located near popular tourist destination of Maithri, was particularly hard hit. A massive landslide, which later evolved into full-scale debris flow, originated from deforested hilltop near Puthumala. The flowing mass carried boulders, uprooted trees, and soil down the slope, wiping out the labor camp and the tea plantation infrastructure. At least 17 people were confirmed dead, and several others were reported missing, and emergency services faced a great difficulty in accessing the affected area due to the washed out roads and unstable ground conditions. So there are several factors which contributed to this vulnerability of Wayanad. Of course, it's related to the physiography, steep slopes, weathered lateritic soil, rock formations, inherently unstable under high saturation of the slopes. Second, of course, widespread land use, change of land use, road cuttings, deforestation, poor drainage. So there are reports that emphasize the immediate and long-term mitigation measures. These include geotechnical slope stabilization, check dams in vulnerable valleys, and imposed surface drainage to reduce the water infiltration. In addition, a forestation program and basically education to the community. Of course, the Wayanad debris flow events serve as a sobering reminder of the delicate balance between the development and the environmental stability in hilly areas. While rainfall-induced debris flow are natural phenomena, their frequency and impact have been magnified by anthropogenic pressures and inadequate management practices. Of course, these can be, of course, clubbed with the, let's say, early warning systems or remote sensing or hazard mapping, so that, the sustainable land use planning can be looked after. Similar but other incident in 2013 in Uttarakhand, there was a tragedy, which was one of the most devastating natural disaster in India's history, caused by a combination of cloudburst, unprecedented rainfall, and rapid glacial melt in Himalayan region. The debris flow particularly affecting the Kedarnath Valley in Rudraprayag district. The Mandakini River basically swollen beyond capacity and swept away entire villages, roads, bridges, while landslides and debris flows buried buildings and blocked the rescue routes. Thousands of people, including pilgrims visiting Kedarnath temple, were trapped. The debris flow consisted of boulders, mud, and glacial material originated from steep slopes, destabilized by both natural forces and the other part of the anthropogenic activities. The tragedy exposed the fragile ecological balance of Himalayas and highlighted the need for stringent regulations on anthropogenic activities, basically construction systems, and better early warning systems, and the alert systems, climate resilient infrastructure, which is at high risk in mountainous region. This is the video. Probably I need to show you the video. This is from the Himachal Pradesh. The video is of this year only. And if you watch the video, you will understand how the soil actually moves as a debris flow. So you have seen in the video that the soil actually literally is washed like water. And this is the photograph from Kedarnath in 2013, and you can see here a lot of debris that's being deposited, which were being brought up from the up hillside. So debris flow is what we are looking, especially the debris flow barrier. So a debris flow is a fast moving mass composed of water, saturated soil, rock, and organic material, causing significant damage to the whatever coming in its way. A debris flow is typically triggered by intense rainfall. And then, of course, it could be a rapid snow melt, could be a volcanic activity, earthquakes, or human activities like deforestation or sudden release of water from a dam. So, for example, in Kedarnath, there was sudden release of water from a glacial lake on the hillside. These events saturate and destabilize loose soil rock, causing it to flow downhill. When we look at the debris flow, let's understand the different zones of the debris flow. Starting with the first zone, that's typically at the hilltop, or let's say the mountain top, referred as a triggering zone. Then you have the second zone, is called as the transit zone, through which the debris flow pass through. And then the runoff zone, the last zone where the debris flow will come to an halt. Let's understand these different zones. The trigger area of debris flow is typically characterized by steep slopes, loose or unconsolidated soil, and a lack of vegetation, which can reduce slope stability. This area often has a high gradient where water can rapidly accumulate and saturate the soil, making it more prone to sliding. The presence of previous landslide material, you can call it as the overburden, bare rock, or the volcanic ash deposits can also contribute to the likelihood of debris flow. Additionally, the trigger area might have a convex or concave shape that funnels water and debris into a concentrated path, increasing the flow's initiation potential. The transit area of debris flow is the zone through which the flow moves downhill after being triggered. This area is typically characterized by a channel such as gully, ravine, or riverbed that guides the movement of the debris. The transit area often has moderate to steep slope, which allows the debris flow to maintain a high velocity. As the flow moves, it can erode the channel, picking up additional material and increase in the volume. The flow may also encounter obstacles such as boulders or vegetation, which can slow down temporarily, but often leads to further accumulation of debris. The transit area is crucial in determining the final impact zone of the debris flow, as it dictates the path and speed of the moving material. The runoff zone, also known as the deposition or runout zone, is the final area where the debris flow loses its momentum and deposits the carried material. This zone is typically located at the base of the slope, often in a flatter area such as valley floor, floodplain, or alluvial fan. So for example, in Kedarnath, there is a mountain all around. And when there was this cloud burst and the debris flow, the Kedarnath area where the temple is, you had a, though it's a small area, it's a, let's say, a relatively flatter area where a lot of debris have been deposited. In the runoff zone, the debris flow spreads out, slows down, and eventually comes to a stop, depositing a mix of coarse and fine materials. This area can experience a significant accumulation of debris, leading to formation of new landforms or altering existing ones. The extent of the runoff zone can vary depending on the volume and speed of the debris flow, as well as topography of the terrain. Now let's look at these different zones, including the, let's say, the transition zone or transit zone, where you can control the flow, where you can reduce the flow and control the debris flow capacity of eroding a soil or accumulation of the or collection of debris, or control of the transportation of debris. Runoff zone or runout zone, where you will need the mitigation of the effects or the deviation of flows, or a basin for accumulation of this debris flow and planning of the inhabited areas. In runoff zone, usually you may have the protection structures like debris flow embankments, or you can have gabion selective check dams, or the debris flow barriers. Here we can see these different types of solutions which can be applied in the runoff zone. So when we talk of the debris flow solutions, what could be the structural measures as a part of conventional solution? Usually the solutions are like the check dams or sabo dams. These are built across the streams. These dams basically trap the debris and they reduce the speed and as well as, of course, the flow energy. In these dams, the water is allowed to pass, but the sediments are being held upon or being captured. Another structural measure is debris retention basins. These are large catchment pits which collect the debris upstream of the settlements or the habitated area. These require regular cleaning and maintenance. So very important part where this kind of problem when you try to solve, don't forget about mitigation. The solution is not going to stop the debris flow, but okay, debris flow happening, but it will control the damage. However, the regular maintenance is required. Another simple solution could be construction of a deflection or diversion walls. In this, the redirection of flow typically direct the flow away from the precious or vulnerable infrastructure or the populated area which you want to protect. These shall be designed to cater the volume of the debris flow and the energy. Next structural measure is, of course, the drainage improvement. As you have seen, even in the slide of Wayanad I have showed you, as well as historically anywhere you see, when you have very high rainfall, when there is a infiltration of water inside the loose soil mass, saturation is one of the issue, and because of that, then the debris flow can be initiated. So if proper surface and subsurface drains are being provided, which reduce the pore water pressure, this can basically improve the stability of the slope, and this can prevent the slope failure that could initiate the debris flow. Non-structural measures like hazard zonation and land use planning. So here, basically in a particular area, need to identify the areas which are prone to debris flow. For this, of course, the geotechnical and geological surveys can be used. And then constructing a high-risk zone. So basically restrict the movements or the construction in the high-risk zones and promote the zoning codes and development regulations specifically for that hazardous area. Early warning systems, like where possible information of high rainfalls, ground movements, or acoustic sensors, which can give a warning of saturation of the soil, as well as if there are any movements can be noted. And these warnings could be real time, which can help to evacuate people before the flow begins. It could be real time, or even it can be alert system, which can pass on the message very quickly. Another non-structural measures could be pre-planting or vegetation, or basically stabilizing the soil, reduce the runoff, where of course you can use the grass, bamboo, shrub on the unstable slopes to make the topsoil to be held by the plant roots. And one of the non-structural measures could be public awareness. So typically training and drills in an area which is hazardous, and installation of the signages giving the escape routes. These could be the non-structural measures. A debris flow barrier typically can be installed in the transit zone. It is a structure which is designed to intercept the debris flow, which is rapidly coming down the hill, which could contain rock, debris, or even the trunk of trees, and prevent them reaching the vulnerable areas. Of course, the number of debris flow barrier to be placed will be governed by the volume of debris anticipated in one event. And of course, how much risk you want to basically cater. So all that is being proportionate. So these debris flow barriers can be constructed using the steel meshes, steel cables, combined with the brakes. The brakes basically will absorb the energy which the debris flow will bring along with them. The design of debris flow is, of course, is a mix of different input information. So where you will need the information from the geological and geotechnical perspective, as well as the characterize the basin or the funnel of the mountain from the hydrological characterization point of view. In the design approach, you are expecting a debris flow. So in the debris flow, there will be a, let's say, a perennial flow of channel or a stream. You will have a constant flow of water, but during debris flow event, you will have a peak flow. Now, when you design the debris flow barrier, you don't design for the regular flow which is flowing, but you design for a peak flow period only, allowing certain amount of flow to pass through the barriers. So that means letting the ordinary flow passing through and retaining the peak or solid transportation of the debris flow. So how do you design this debris flow? What's the approach that has to be followed? In this, of course, first you need to know the channel geometry. The channel geometry is required to understand the dimensions of the barrier to be installed. And then you can check whether the barrier dimensions are being certified or not. The second check is the volume of debris that's going to come down. The volume of debris will govern how many number of barriers you require at a particular site on a particular stream. The third design is basically the design related to the structural part, where you need to understand the debris density, anticipate the flow of the debris, what could be the height of the flow of this debris, and accordingly you design the barrier for static and the dynamic impact. So let's look at a debris flow barrier. For example, in this photograph, you are looking at the trapezoidal section in which you are going to put these meshes. Of course, the barriers are to be certified and CE mark barriers. Now the question comes, how exactly these barriers are certified? So there is a European technical approval, basically, which defines the two group of products, debris flow barriers and shallow landslide barriers. In this, there is a methodology to conduct the full-scale test for each group. And then there is a methodology to assess the product performance. For understanding this, there are two options. One is based on the full-scale test, which is applied to one single product, or you can have option 2, where you can have a numerical model, which is calibrated by the 2 tests performed on 2 different products of the group. And then you have a numerical model, and then you finally have the European technical approval, and finally you have the CE mark. Let's look at the components of the debris flow. The components of debris flow are the panels, the cables connections, the abrasion plate. So this is the abrasion plate, the upper cable connections, the intermediate cable connections, and low cable connections. According to the EAD, the flexible barriers, the flexible debris flow barriers, you can design them by considering the impact pressure of the debris, the filling pressure, and the overload flow. Usually these barriers are defined based on the pressure. So for example, there are 2 types of barriers, the SC and LCP, basically a narrow channel barrier and a wide channel barrier. Narrow channel barriers are applicable up to 15-meter width on the top, and the wide channel barriers are applicable up to 25 meters top width. These barriers can sustain a pressure of 65 to 165 kPa or 65 to 185 kPa for both narrow and wide channels respectively. So the debris flow risk assessment is part of need and expertise insight to understand the hazard evaluation and implementation of tailored production solutions, which of course ensure the comprehensive safety and performance mitigating the debris flow impacts. For designing, of course, can assist in creating customized solutions that ensure effective mitigation of debris flow risk, taking into the account specific site conditions and safety requirements. Very important part, any structure designed, construction is very, very important. So for installation, there need to be have a guidance on the site for ensuring the correct and efficient installation of the system. And of course, this guarantees the optimal performance of the debris flow mitigation. As I briefed earlier, there is requirement to have these barriers to be ETA and CE certified. Along with that, the manufacturer must give the declaration of performances. After the installation, the another part important is basically declaration or the certification of correct installation has been done. This will ensure the proper functioning of the debris flow barrier, ensuring the long-term effectiveness and compliance with safety standards. Along with that, the debris flow barriers are essential to safeguard against nature's unpredictability and standing resilience against boulders and landslides. With Hellomac Geo, these barriers become smart systems. They can gain a comprehensive monitoring capabilities with 8 sensors meticulously positioned and supported by 8 legs. So in the next session, I'll explain you about this IoT technology. Just to give an idea of what I mentioned earlier, it's important to have an alert system or a monitoring system where a robust construction enables to withstand such hard conditions and reliable performances. Moreover, the alert system or the monitoring system, what you put, must have a proper coverage and working throughout its life so that you get a proper information at the end. Another important part to be understood is about the construction aspects that's related to the planning, quality, and safety. When we talk of the construction aspect, most important is the construction sequence. So when you have to install the debris flow barrier, first, of course, we will have to have the identification of site, and then, of course, the installation of the anchors, then the placement of the ropes, and then, of course, you have the installation of the meshes. Here, of course, depending on the site condition, you will need to choose the right machinery. Whether the work or the construction to be done pre or post monsoon is very, very important. Of course, if you are trying to do something during monsoon, then you are likely to have possibilities of debris flow during construction itself. Extreme rains and colds need to be understood, and accordingly the planning has to be done. The quality, of course, as I mentioned, important part. Any structure design installation is very, very important. So experienced people at site monitoring the construction are, let's say, the mandatory requirements. And then if you have the proper checklist to monitor the installation, then you can guarantee the quality. The signages, barricades, temporary protection are part of safety, and most important parts, again, the maintenance. Once you install these barriers, you will have probably an impact of debris flow, but later on, the debris flow to be effective, barrier to be effective, you will need to take care of the maintenance activities, visiting the site and looking at it. Apart from that, the in-situ test and checks to be performed. So for example, when you install the site anchors, the soil anchors, rock anchors, you can do a site-specific test and ensure the construction is correct. Now moving on to the case studies. This is the first case study from Turkey, which experiences most of its avalanches and debris flow in the northeast part of the Anatolia, a region replete the mountain valleys, rivers. These events of nature interrupts transportation and communication lines along their potentially deadly impact on life and loss of property. Contributing to their frequencies is land use of form a new road and railway, new residential developments and expansions of arable farming lands. In addition to the effects of climate, geology and hydrology, the denuding of forest areas of a human purposes exposes the soil to nature's elements, triggering the sliding movements of soil pulled by gravity downward seeking equilibrium. Particularly troublesome is basically the debris flow. In some cases, the speed of the movements are very, very high, especially when they are combined with the rainfall. As debris flow barrier, they are made with the steel mesh and advanced energy dissipation braking system. This is first time used in Turkey in 2017. A test site was chosen by authorities in Göksu district of Rize province, in tributary of Kotomaya River in Bahoskoy. Regarding the calculation, the barrier was installed in a trapezoidal shaped stream bed. Barrier has a height of 3 meters and 9 meters across the top and 3 meters at the base with a resistance of 160 kPa. The test area was chosen after considering many criteria such as geological conditions, optimum anchorage location, and site accessibility. The tributary runs seasonally through the culvert under the traversing footpath before joining the larger tributary downstream. So in this case study, you can see the barrier was installed, and this is after installation. The barrier has stopped the debris. This is another case study. This is from Philippines. This is the Lakewood municipality city, which poses the or receives a lot of threats of debris flow due to its proximity to the primary drainage system of Mount Lumbing Basin. Numerous residential and public structures are at the risk of being affected by this debris flow unless appropriate measures were taken. Despite inherent dangers, the DPWH engineers diligently exploring and gathering the potential solutions of mitigating debris flow, where McAfee Philippines has introduced debris flow barrier as a primary hazard mitigation strategy, which they have shared and presented. So obviously, the McAfee Philippines has suggested implementation of 2 tiers of debris flow barriers with a strength of 160 kPa. These barriers are strategically constructed along the main channel of Singdan Bayong Lockwood Road. Their design is robust enough and managing the debris flow resulting from heavy flooding, thereby safeguarding the communities and public infrastructure. The next case study is from State Highway 73 from New Zealand, which is a major motorway connecting the regions of Canberra and West Coast. It provides access to many recreational sites such as the ski fields during winters, and it's vital for economic as well as well-being of the West Coast region due to the increased traffic movement since opening of the highway. The client had accepted the proposal to install the debris flow barrier, capturing the 300 cubic meter of debris flow volume accumulated from consecutive debris flow events. The debris flow fence considered both dynamic and static components of the imposed pressure by debris flow. These components are then distributed to the ring panel, and which then transmit load to the longitudinal cables, and the cables active energy dissipators finally transmit the loads to the lateral anchors. So in this, the ICAF 4422 anchors were installed up to 10-meter length, and there have been subsequent debris flow incidents reported after completion of barrier installation, and barrier successfully prevented any debris from intruding into the motorway. This is another project from state of Maharashtra. This is near Nashik, Kalwan area. This is 165 kPa barrier of a height of the 4.5. This is a barrier of LCP type, that is a narrow, wide channel barrier. This is another case from the New Zealand, where the open type of barriers are being installed on the slope. So in a summary, you need to have a holistic approach to develop these solutions, not only geotechnical, geological, but hydrological studies to be seen. Suitable engineering investigation data is required. Important part, construction feasibility to be understood, where you will have the accessibility to install the anchors. And then, of course, as I explained, any structure designed, you need to have the proper quality control, the checks to be done. Safety is, of course, one of the important part, and you can include the alert system, which will make the barriers smart, which will help in understanding the timely maintenance of the barriers. So with this, I thank all of the audience for patiently listening. I end my talk here. And I would be more than happy to answer your questions. So please do put your questions in the chat box. Thank you.
Okay. So thank you, Dr. Ratnakar, for the detailed presentation. So now, as you already said, that we request everyone to type your questions in the chat box. We'll be taking the Q&A session for all these 3 recent sessions after the next session that we have in hand. And moving to the next session, we have speaker Mr. Pierluigi Basito, who will present on IoT-based solutions for resilient infrastructure. Mr. Basito is the CEO and founder of NESA, a leading company in the field of environmental monitoring and early warning system based on IoT, Internet of Things technology. Established in 2004, a highly skilled electronic engineer, Basito brings a cutting-edge technological vision to the concepts of prevention and safety. Under his leadership, NESA has become one of the key players in global market for environmental monitoring and alert system. Please welcome Mr. Basito.
Thank you. Let me share my screen for the presentation.
Yes, it is there.
Okay, you should see correctly.
Yes, we can see, yes.
Perfect.
Yeah, it's there. You are audible also.
Okay. Thank you to all, and good afternoon. Thank you for the introduction. After the debris flow mitigation made by Dr. Ratnakar, let's see how we can create an early warning system based on debris flow events. You know that mountain regions across the globe are increasingly vulnerable to the debris flow events. Rapid movement of rocks, soil, and water can devastate communities with a little warning. Climate change is accelerating these risks because there are more frequent intense rainfall and melting permafrost, and not only. The traditional mitigation efforts alone are not longer sufficient. There are a growing need of a proactive monitoring and early warning system that enable faster, smarter emergency responses. saving lives and reducing damage, of course. Let's start with the local context. This is the area of Sonico, located in the Central Alps of northern Italy. It is a landscape of breathtaking beauty, of course, but also significant
Mr. Piolucci?
geohazard. Sorry?
Sorry to interrupt you, but I think we can see this gray bar towards the extreme right side of the presentation of yours.
Okay.
Can you
Let me
reshare your
pass.
screen? I think it will hinder
Is better?
the.
No.
No, not actually.
I don't
It's
know. Okay. You see, let me. It is okay now?
Yeah, it is better now.
Oh, sorry. Okay.
Okay, it's fine. Thank you.
No problem. I say that the context is this area of in the northern Italy, but is an area with a significant geohazard. There are too many geological features shape that risk profile of the region. The first is the presence of an ancient paleo landslide known as the PAL name along the Gallinera Valley. This is a depth-seated dormant mass of movement that has the potential to reactivate under certain conditions. Second, the side valley of Arabia, which periodically releases high energy debris flow, fast-moving mix of water, mud, and large rocks. These events are typically triggered by a combination of intense precipitation and permafrost degradation at higher elevation. In this area, freeze-to cycles, rapid fluvial erosion, and climate-induced shift in weather patterns amplify the instability. So we are dealing with a complex system, very complex system, where multiple natural forces interact and where even modest changes in rainfall or temperature can lead to devastating outcomes. Have a look here. This is the mitigation system made many years ago with a wall 11 meters of height and about 30 meters of wide. Let's see what happened in July 27, 2012. This fragile balance has been broken by an intensive event. Let's see. Quite impressive, isn't it? After a series of heavy rainfall events early in the month, an highly localized storm cell released an exceptional amount of water, 180 millimeters of rain in just under 20 minutes. That's nearly a month's worth of rain in the time to take a dinner. The soil was already saturated. The final storm acted as a trigger, mobilizing around 400,000 cubic meters of debris, which cascaded down the valley at a speed reaching up 10 meters per second, and the Reno Bridge, located at the bottom of the valley that connects the village and Reno and Sonico towns, disappeared. It was got washed away by the debris flow, whose the flow rate was estimated around 1,840 cubic meter per second. So very huge amount of debris. Furthermore, from the analysis of the later images, the average ground level has risen of about 4.5 meters. So you can imagine what happened in a few minutes. This is the typical phenomenon that we have also now there in this part of Italy. The destructive force was immense. The main road through the valley was cut off. Bridges were swept away and homes were drained. The Reno Bridge, one of the key connectors between settlements, was destroyed. But perhaps most alarming was the unpredictability. There were no early warning at that moment. the event unfolded rapidly, leaving very little time for emergency response. But this disaster became a turning point, and it prompted the local authorities to rethink the risk management, not just in terms of structural defense and mitigation, but also in terms of detection, alert, and timely evacuation, because it's important for the community safety. In the aftermath of the 2012 disaster, authorities moved quickly to understand the causes of the disaster. And in an in-depth analysis of the river channels, they highlighted some critical aspects, including the instability of the riverbanks made of compacted earth, the shallow depth of the riverbed, and its modest cross-sectional area. So they decided to make some mitigation simply with applying the traditional mitigation strategy, implementing an upstream banks were built to slow the debris, a downstream banks where reinforced detritus channels were built, and even the bed of the Oglio River was lowered and widened to accommodate future sediment loads. These were essential for first step, critical for protecting key infrastructure and reducing downstream impact. But they all shared one limitation: they were passive. They didn't detect or predict an event. When dealing with fast movement of debris flows, every second matters. Without a real-time situation awareness or warning, the defense offered no opportunity to evacuate people in time or to prevent exposure to loss of life. That's where a more integrated, proactive approach was needed, one that could provide automatic detection and timely alerts, especially during the night or in bad weather conditions, when response time is even more critical. So, in response to this need, an early warning system was developed in collaboration with the local municipality. The aim was to go beyond the structural defenses, introducing the dual-layer system, combining meteorological monitoring and physical debris flow detection. The first layer uses weather stations to monitor the rainfall intensity and temperature, especially relevant due to the role of the permafrost melt. The second layer instead consists of an innovative sensor system known as tear-off sensor or ELOMAC Geo. Is a mechanical device that is physically connected to large boulders in the debris path. If a boulder is displaced, something that only happens in case of a debris flow or a landslide, the sensor is triggered. This provides a binary confirmation that hazard events is underway, something is happening. The goal then is combine a predictive alert with a physical confirmation, allowing the authorities to act confidently and immediately. Let's take a closer look at the technical setup. The system covers an area about 7 by 2 kilometers. It includes 2 weather stations placed at the key elevation to detect intense rainfall and temperature variation. We are speaking about 2,400 meters of elevation. 6 tear-off sensor ELOMAC Geo, each one connected to a boulder of at least 150 kilograms of weight, either naturally occurring or placed for the purpose. 2 radio concentrators positioned in a safe zone within the valley, creating a redundancy in the communication network. 2 sirens in Sonico and Reno, plus 2 traffic lights to stop vehicles on the vulnerable bridge, and 2 remote cameras positioned at about 3 kilometers downstream for visual confirmation. The entire system is able to operate on a private LoRaWAN network that is ideal for isolated alpine environments or in areas where you don't have any power and any coverage. It's built for endure extreme temperatures, humidity, and wind exposure. This is not just a robust technology. It is carefully adapted to the environmental and logistical challenge of the region. So the system has been designed specifically to support the application in hard conditions and in area where you don't have any power supply, any coverage in terms of data transmission, and where it's not easy to make the installation. Let's see how the system works. We have a set of instruments that are spread in the area, and the radius of the area could be from 5 to 8 kilometers far from the concentrator. The concentrator is called the gateway. This device is capable to collect the data coming from all the sensors. We can say that is able to collect up to 100 sensors, collect the data and retransmit the data in the cloud for disseminating the information on to the authorities or to the person in charge in terms of information in your range. That takes 2-3 minutes according to the kind of coverage that we can use at the moment. And locally is able to make immediate commands like switch on traffic lights, siren, and so on, in a time that is between 1 and 4 seconds. So you can imagine that after the detection of the debris flow movement boulders that come down from on the hill, we are able to stop the traffic in a time that is between 1 and 4 seconds. The system logic is based on a two-stage trigger model. We can say the pre-alert and confirmation. The first, the weather station monitor rainfall in real time and also the temperature. If predefined thresholds are exceeded, we can say 3 millimeters in 5 minutes for level 1, or 10 millimeters in 5 minutes for the level 2, a warning level is triggered. These thresholds are based on local geological analysis, course, and historical events are information that are coming from the specialist. And when something happens, the fire brigades are pre-alerted and prepared for a possible intervention. We can say, be ready because something can happen. It's not happening right now, but can happen. The second is the confirmation. If any of the tier of sensors are triggered, indicating an actual movement of the boulders, the system instantaneously activated, the alarm goes off, and what happens next is fully automated. Siren sound in both towns, traffic is stopped on the bridge, and the authorities receive the notification via SMS or email, and the firefighters are dispersed. All this takes place within 1 or 2 seconds from the event, eliminating human delay. This automation is critical, especially for nighttime events or during the storms or in bad weather conditions, but it's not possible to manage in other way. So it's a very important and interesting way to solve the problem. The system has been designed for this kind of terrain, and it isn't so simple. It is a typical the typical operation condition are altitude above 2,400 meters, temperature that during the winter reach 30 degrees below zero. There are no electricity, no mobile coverage, very difficult to assess, often require helicopters and so on. That's why each component of the system was developed to be self-powered using solar energy or battery, long life, about 10 years. The tier sensors are fully autonomous in terms of energy and in terms of data transmission. The network for data transmission is developed and based on a private LoRaWAN network. And the system also needed to be easy to install, even at high altitude and durable, with zero tolerance for false, positive, or missed alerts. We reached in over 12 years of operation, the network has not generated a single false alarm, thanks to the clear trigger logic based on the physical rope movements. The maintenance needs are minimal. With the remote monitor, typically is more than sufficient. This makes it a cost-effective and long-term solution for all remote regions. It is a solution that saves lives, and since its first activation in 2012, the system has been successfully triggered multiple times, most recently in 2020 and 2023, when approximately 250,000 cubic meters of debris dislodged from the Gallinaro Valley and flowed downstream, some boulders at the size of a pickup truck. In each case, the population of Reno and Sonico was alerted and evacuated in time. No injuries, no fatalities were reported. The model is scalable. It works in any terrain or with similar kind of a SAR. It doesn't require any kind of external power or telecom infrastructure. It provides predictive and confirmatory data, enabling fast and confident decision-making. The lessons here are the globally applicable. From the Alps to the Himalaya, many regions face similar risks. The solution proves that with the right design, the technology can close to the critical gap between other detection and life-saving action. But the last but not least, the debris flow is only one of the phenomena that we can cover with this kind of technology. Because you know that after a study made by the World Bank, it's well known to everybody, the disasters caused by natural hazards are increasingly threatening lives and livelihoods. Climate change is further exacerbating the negative impact of disasters caused by natural hazards, and it's proven that in the last 20 years, the numbers of events is twice compared to the previous 20 years period. The United Organization said that if we provide a 24-hour early warning system, we can reduce the damage due to environmental hazard up to 30%. So it's very important to invest in early warning systems. Another example, indeed, that we can cover with this kind of technology is the erosion of the bridge and creating an IoT alert system for this situation. Heavy rains, flash flood, debris can cause erosion at the base of the bridge piers with a possible collapse. And you know that also in India happens recently. So the solution is the same used for the debris flow with the pre-alert and the confirmation. The pre-alert is based on the water level measurement, the monitoring of the water level, and especially the increasing of the water level, not only in terms of amount, but also in terms of speed of the increasing of the water level. We can set a trigger, different trigger for creating the pre-alert and inform the brigade for be ready if something happens. And we can have the confirmation only when the bottom of the piers is damaged or there is the erosion phenomenon. There is a displacement sensor that is triggered on the movement of the bottom of the river and create the alarm, so all the alarm goes off. And again, as similar to the debris flow, we can activate siren, traffic light, and dispatch the firefighters. How is made the system? Let's go to see the solution that for Macquarie is called Smart Bridge Monitoring. Essentially, it is based on two kinds of solution. One is the common technology for measuring the water level based on ultrasonic or rather sensor that measures the water level. And the second is called ELOMAC Hydro. It's a displacement sensor that permit to detect the movement of a ballast that is positioned in the bottom of the river, in the downstream side of the river, or of the ridge, sorry, and is able to detect when the erosion permit the movement of the ballast. The sensor detects the movement due to the erosion and activates the alarm. Indeed, consider that monitoring rivers near infrastructure such as bridges and so on is crucial, as issues like high water level, intense peer erosion that can compromise the structural stability. Elomag Hydro is an early warning system designed to enhance the safety of the bridge, offering an all-in-one and innovative solution based on IoT technology that permit to detect the erosion and the water level change in real time. So we can say that through the typical transmission made by satellite, GSM, 4G, we can get information by app, by SMS, or by email on what about is happening. Locally, of course, we can activate siren, traffic lights, and so on within a few seconds, and the information in your hands arrive in about 2-3 minutes, according to the kind of communication line we are using, satellite, GPS, and so on. At the end, we can say that the technology has been developed to improve the safety of our communities. And this kind of technology developed by Michael Ferry assure the possibility in a simple way to improve the safety, to get the information about the monitoring and the confirmation about the alarm that we can get with this kind of devices. That's all for my presentation. Thank you for the attention.
So thank you, Mr. Baseto. It was a very nice presentation. And so with this, we are at the end of the third session after basically the recess. So now we are into the Q&A session. So we'll be taking the questions that we have received in the chat box. So I would request everybody to type your questions in the chat box. We shall take one by one. So we'll start. I think this question is from Mr. Spadaro. What is the maximum temperature MACMAT can sustain? This question is from Mr. Pradeep Kumar.
Yeah, regarding the maximum temperature, we can refer to, just to provide an answer, we can refer to the melting point of the geomat of our MACMAT is 160 Celsius degrees. So it means that we have not to refer to the melting point because, of course, 160 degrees, no vegetation will be there. But instead of, we have to refer to the air temperature that will be transmitted to the soil. And then basically the temperature on site will be something between, okay, depends on the, of course, on the area where the project site is located, but it's something that could be below zero and till 40, 50 degrees above zero, something like this. As we have seen during the presentation, the color of the MACMAT is something that will influence the temperature of the mattresses and then the temperature of the soil influencing the germination process. Then the capability to have the material in different color may help to reduce the peak or improve the temperature in cold region where an improvement of the temperature will be beneficial in terms of development of vegetation. So basically, there is no issue related to the temperature capable to be withstand by the mattress. We have to refer to the air and then the soil temperature. That no issue regarding the usual and typical air and soil temperature where the material is submitted.
Okay, thank you for taking this question. So another question, again from Mr. Spadaro, and the question is, what type of soil is suitable for erosion control by geosynthetics? Question is
Yeah.
from Mr. Debabrata Sinha.
Yeah, basically, soil need to be not sterile. So it means soil has to allow the development of vegetation germination process. So any kind of soil, but allowing the development of vegetation. Using erosion control product, we may provide a physical protection against the action of the eroding agents, and so limiting the soil loss, and then creating a favorable condition, promoting the germination process and the development of the vegetation. And it's the reason why, according to the specific soil that will be encountered on site and the specific weather and climatic condition, exposure, moisture, and content, we have to work closely with an horticulture company in order to define the specific mix of seeds to be used in order to get a successful intervention on site.
Okay, thank you for taking this question. So we'll be moving to our next question. Just a second. So, so out of all these solutions presented, this is on the Mr. Gianluca's presentation. Out
Okay.
of all the solutions which we have presented, which is the most effective solution that we have?
We cannot reply in principle which would be the most effective. As we have seen during the presentation, Russell equation could be an effective tool, an effective instrument in order to judge the effectiveness of the solution. So basically, we can use the Russell equation, the Russell approach, in order to identify the solution providing the most suitable effect. So it means according to the Russell equation, we can evaluate the average soil loss, and basically the solution associated with the lower average soil loss will be the most suitable for the specific condition where the project site is located. As we have seen, the Russell equation is involving different factors covering rainfall, covering the different type of soil, and the inclination of the slope, all the things that are correlated to specific project sites. Using the Russell equation, we can judge which will be the most suitable solution.
Okay, thank you. Another round of question from Mr. Mohammad Nizamuddin, and the question is: this solution of this type of solution can be useful. Can it be useful for useful in desert or sandy area like Rajasthan state? So probably for the erosion
Yeah,
control
but-
solutions,
Yeah,
Mr. Khan is asking. Yeah.
Yeah. Basically, we have already replied to this question. Basically, erosion control solution can work in every kind of type of soil, but need to be not sterile. So it means it need to allow the development of vegetation. So it means that if even if in arid region, in desert region, we will have, if we will have a soil capable to allow the development of vegetation, if something can be covered using erosion control product in order to limit the soil loss and promote a favorable condition. But of course, in such kind of region where growing the vegetation is quite challenging. We need to work in close contact with an horticultural company in order to identify the specific mix of seeds and the specific additives need to be added in the hydro seeding mix in order to improve the chance of success of the interrogation.
Okay. Thank you, Mr. Spadaro, for taking all these questions. So we'll be quickly moving on to the next set of questions that we have. And the next question that we have is on debris flow. And question is, if
Yep.
the debris flows over the mesh height, then this strategy will fail. Is it right? And this question is to Dr. Ratnakar.
Okay, thank you, Sumit. It's a very interesting question. So, the flow over debris flow barrier mesh, whether the flow is over the debris mesh is right, if it flows right or not. So, the answer will lie based on the strategy that's being adopted. For example, the amount of debris which are expected or anticipated in a channel and the amount of debris are very high compared to the possible accumulation of debris behind the barrier. In that case, you will provide multiple barriers. That means maybe 2 or 3 or 4 barriers. In that case, obviously the first barrier on the hill slope will overflow, then the debris flow volume will go to the second barrier, then it will overflow, then the third barrier and the fourth barrier. So it's not always to say that debris flow barrier to contain whole debris in the mesh. No, there will be possibilities of the debris flowing over the mesh itself, and that's why even while designing you need to consider that. The idea of debris flow barrier is to contain debris, not all of them, but another idea or the philosophy is to reduce the speed, to reduce the kinetic energy. So it's not right to say that if the debris flow over mesh is the strategy is failed, not like that.
Okay, thank you, Dr. Mahajan, for taking this question. So next question that we have is again on the same topic. Any performance assessment of these barriers?
Yeah, so what I have described earlier, the barriers basically are classified based on the pressure. Let's say 60 to 165 kPa or 65 to 165 kPa. So these barriers are actually designed for these pressures. So the components of the barriers are being already tested in a full scale. So as a part of certification program, as per the EAD, the barriers have to be tested. There are two options. One is you test the barrier full scale for a given geometry or slope, and the option two is you test the barrier as well as you have a numerical simulation. So in a way, it's a prototype full scale test that's being conducted, and that's how the performance of the barriers is being determined, and accordingly these barriers are designed.
Okay, thank you. So another question in this set, that how is the capacity of the barriers are decided?
Yeah. So thank you again. It's what I mentioned. The capacity of barrier will be decided based on volume. So you know the geometry of the channel, you know the slope of the hill, so you know what's the possible amount of volume it can hold back. So that's one is the volume, but the barriers are designed based on the pressure, not on the volume, and the pressure is decided based on the filling pressure, impact pressure, and when the barrier is full, then the geostatic pressure. That's how the capacity of the barrier is decided.
Okay, thank you, Dr. Mahajan, for taking this set of questions. So we'll be quickly moving to the third set of questions that we have, which is on IoT-based solutions. So the first question we have is from Mr. Akhil Agarwal, and question is, please share any early warning system which can detect windstorm up to 50 meter per second and above in a barren land. This question is asked to
Sorry.
Mr. Pierluigi.
Yeah, okay. The early warning system for wind monitor is another kind of device. Of course, we can provide also this kind of solution, but it's based on a different sensors and a different kind of approach, because normally the problem with the wind is related to the gust. So we should have a system capable to detect and to monitor at high speed the wind speed. High speed, I mean high rate, to make the samples of the wind speed to detect the gust. It's possible to provide, but it's not part of the geotechnical application. It's a part of the environment monitoring system that we can provide.
Okay, thank you, Mr. Pierluigi, for taking this question. So another question that we have is the mountain case study alert system AI based, or does it rely on predefined hard-coded algorithms? If it uses hard-coded algorithm, how is debris flow initiation specifically defined or modeled within the system?
Interesting question. No, it's not based on AI algorithm or application, for the simple reason that we divided and to create a system that must be scalable everywhere. The system has been divided in alerting, early warning, and confirmation. The early warning is based only on the information, historic information, or information that can be collected along the time related to the rain and to the temperature, soil temperature, and air temperature of the area where we have to install the system. Of course, we can set a different threshold, and maybe some one of them are wrong, but it's not a problem, because it's possible to define a lot of threshold, and the information that we can get from this threshold is only an alert, not a confirmation. The confirmation comes down from the tear-off sensor. The tear-off sensor are based only to the movement of the boulders. So if we decide to connect the sensor to a big boulder, 200 kilograms, for example, of course you can imagine then the boulders can start to move only for an important phenomenon like debris flow, not for a simple water and so on. But the confirmation arrives when the boulders start to move. So it's not necessary to apply any algorithm, any specific algorithm. It's like to the alarm in your house. When the door is open, you receive the alarm. When the boulders start to move, you receive the alarm. The important thing is decide where to install the sensor, because along the example, along the path of the river in the example in Italy, it was about 5 kilometers, and we decided to put 3 sensors on the left side and 3 sensors on the right side, just to have enough time to stop the traffic. I mean, from the beginning to the valley, the debris flow takes about 3 minutes to arrive. And in 3 minutes, we can stop the traffic and try to evacuate part of the population, the closer population to the river. This is the only thing that we took in consideration at that time. No other algorithm, no, nothing necessary.
Okay, thank you for taking this question. So we have our next question in the similar set, and the question is how the sensor behave during the earthquake? Do they provide any sign during earthquake? Also, what is the frequency of testing the work condition of these sensors?
Another good question. The sensor is not only tested, but is certified at 100 G of acceleration, shock acceleration. This means that earthquake, a direct impact of boulders on the sensor or similar events doesn't create any problem to the sensor itself. The sensor continues to work. Of course, if you have an earthquake that creates a movement of important boulders, can be detected as an alarm. Each sensor is able to detect more than one boulder, so you can connect up to 4 or 8 boulders to the same sensor, just to be sure that in the position where you want to monitor the situation, you have the right information. So also the earthquake can create a debris flow, but it's a different phenomenon, because in this case there is no rain, no water inside, and often you have the movement, but after all the boulders arrive to the bottom of the hill or stop in the middle, depending on the situation. But in any case, you must be informed.
Thank you. The next question that we have is what are the geotechnical instrumentation that can be adopted from monitoring the debris flow and its effect? This question is to Mr. Pierluigi.
Yeah, you are speaking about the monitoring and not the confirmation, not the alert.
Yeah.
The system that we provide is a system capable to collect in a single receiver up to 100 sensors, as I showed you during my presentation. 100 sensor means 100 devices that can be a mix between alert and confirmation. Hellomac Geo, that is the confirmation sensor for the alert, can be installed everywhere, but you can include sensor for the climatic condition, weather station. You can include a displacement sensor for monitoring a small displacement of rockfall, or geotechnical instrumentation like clinometers, load cells, and so on. Depend on the study, the case study you are following. Of course, we can give you some suggestions. We can provide an assistance for developing the project to the customer, but is the specialist that, or the geologist that is able to suggest which kind of measurement is necessary. We can provide the whole system, including monitoring and alert. This is only an example of a case study that we did during the past years.
Okay, thank you. So the next question that we have is for Mr. Spadaro. And the question is, what is about the durability of the solution of the erosion control measure with geosynthetics from the consideration of exposure of the material to sunlight, UV, and atmospheric agents?
Yeah, as mentioned during the presentation, typically we classify erosion control product, erosion control solution in two main classes regarding the duration: temporary solution and permanent solution. When we are referring to permanent solution, to avoid any kind of misunderstanding, since we are referring to synthetic material that will degrade under the action of the UV, material need to be protected by cover soil and vegetation. And finally, the target of any erosion control intervention is to get a full development, a full coverage of the slope provided by the vegetation. So, erosion control solution can provide a long-term protection only if properly shielded by cover soil and natural vegetation coverage. Then, in this case, no issue regarding durability. If the erosion control product will remain directly exposed to UV action, then they will suffer for a degradation of their performances along the time.
Okay, thank you. Another question again to Mr. Spadaro.
Okay,
Can
sure.
the erosion control measure be directly be adopted directly over sandy soil embankment? Does there any of the laying some minimum thickness of clay soil over sandy soil embankment on which erosion control measure protection should be laid?
Yeah, yes. Basically, I think this is quite correlated to the question that we have received before regarding this arid soil and sandy soil. And again, erosion control products can support and promote the development of vegetation on which every kind of type of soil, but need to be not sterile. So need to be capable to allow for the development of the vegetation. So in case of, I'm not referring to sandy soil, but in case of we'll have to face a sterile soil, in this case, you have to allow for the installation for the lane or of a certain thickness of vegetative soil, allowing for the development of vegetation. It would be 20 centimeter, 30 centimeter, and then specific solution need to be identified in order to ensure the stability of this vegetative soil on top of the arid and sterile underlying layer.
Okay. Thank you. So I think with this, we will conclude the Q&A session. And I would like to thank all the three speakers, Mr. Spadaro, Mr. Baseto, and Dr. Mahajan for their presentations. And now, before moving to the next session, so our next session will be presenting from, he is not here in India, he'll be presenting from US. So we would like to take a quick 10-minute break so that we can quickly assemble at 16:25 and then we can proceed with the session again. So let us take a 10-minute quick break. Thank you. Thank you
Thank you.
for it. Yeah.
Thank you.
Thank you.
Thank you.
Thank you. Thank you.